Hello, it's Keith here, and this is lesson 1 of the platform-specific series for my PDP-11 assembly programming tutorials. In this series, we look at various tasks like drawing graphics, reading the keyboard, things like that, and we go through a different task each week and we learn how to do it on all of our systems. Now, in the case of the PDP-11, we're just going to be looking at the PDP-11 server and the UKNC, which is a Russian sort of home and educational computer, which was based on the PDP-11. Those are the two we're going to be looking at, and today we're going to be learning how to work with the keyboard and the text screen. So we're going to be reading keys from the keyboard and writing text to the screen, and effectively this is also going to be a hello world example. We're going to be looking at a slightly more enhanced hello world example, and we're going to learn how to compile programs and run them on the two machines, because I didn't really want to create a hello world and repeat the exact same content a second time. It wouldn't really feel justified. So we're going to cover both of those together in the platform specific series. Now, first of all, I want to discuss how the PDP-11 server CPU actually worked and how it worked with the screen and keyboard, because I think that's important when it comes to discussing the UKNC as well, because the UKNC effectively emulates the PDP-11 in this way, because the UKNC can basically run the PDP-11 software, to my knowledge anyway. Now, the PDP-11 is a very old machine from the 70s, the server was, so it didn't work like a modern Windows server or anything like that. A modern computer, of course, has a keyboard and a screen plugged straight into it. Now, the PDP-11 really didn't do that. It would use a terminal, which was a standalone unit, which you can sort of see here. I've got a picture from Wikipedia here. And this would be basically a keyboard and a monitor, and that keyboard and monitor would have some intelligence of its own to be able to interpret data being fed back from the PDP-11 and turn that into an image which would be shown on the screen. So rather than a sort of relatively modern machine which would have an analog cable coming from the main tower unit to the screen which would have a signal, the PDP-11 server will send characters to the terminal, and these are much more like a printer, and the PDP-11 terminal will interpret those characters and build them into a text screen, and also read the keyboard and send those as characters back to the PDP-11 server. So that's how that worked. Now, I should point out I'm in my early 40s now, and I've never actually used a terminal. I think I saw one once at a place I had a holiday job when I was quite young, but these are very old technology, and in none of the businesses I've worked with they've ever had them. So if you're not familiar with that, or it seems very weird to you, don't be too surprised if you're a younger viewer. It's inevitable, really. But anyway, the UKNC didn't work like that as such. It essentially simulated that kind of functionality. So we talk to the keyboard and the text screen on the UKNC in the same way, but you can see the UKNC's got a built-in keyboard, and I guess it plugged into either a TV or a monitor. I'm not quite sure. I don't own one. It's a fairly rare machine, but I'm guessing it probably had some kind of maybe an RGB monitor, because it was designed for educational purposes, I believe. So anyway, the point I'm making is the UKNC is very much like your Spectrum or your BBC Micro, but the server is a very different beast that was designed to be effectively remote controlled by this terminal. Now, why is that important when it comes to programming? Well, we're going to effectively have to talk to the screen and the keyboard using two pairs of data ports for reading and writing data from the keyboard, writing data to the screen. Now, the first port is a status port to check if there is data ready to read from the keyboard, or whether the screen is ready to receive data in the form of characters. So we have two pairs of ports, and we're going to have to use these. You can see the numbers here in octal, so we're going to be using these, and that's how we transfer data to the hardware. Well, let's go over to our source code and let's start having a look at it. Here's the program for today, hello.mac. We can't call it hello world because of the character limits on this system. We've got 6 character limits for everything, so we're keeping our label names quite short, but fairly descriptive anyway. Let's run today's example. Now, today's example does a few things. It's quite a combined example, so let's run it on the R11, which is our PDP-11 simulator here. Okay, so first of all, we're showing the message hello world here, because it's a hello world example. That's good. And then we've got our monitor function, and this dumps all of the registers to the screen. This is for debugging, and this was something I used quite heavily in the original tutorial series, or derivatives on it in some cases, but it's very handy for doing some testing and seeing what's going on. And then here are some lines of dumped memory, and this is the memory dump, which is also very handy if things are going wrong on you. And then the final thing we've got is if we press some keys here, You can see they're being dumped to the screen. Or it looks like I've got maybe a debouncing issue here on this system. Maybe I need to wait for the buffer to clear before I return execution to the system, because it looks like it's reading old keys and they're turning to lowercase for some reason. I don't quite understand that. But anyway, that's the first version, the R11 version. And then if I compile this again to the UKNC, now this is the exact same code here, because the UKNC is effectively PDP-11 compatible in this extent anyway. If we're doing more complex things, maybe it would be different, and it's certainly different with the UKNC's graphics because the PDP-11 can't do that. So anyway, here you can see hello world again, here you can see the registers again, here you can see the mem dump again, and if I type ABC, we don't have that debouncing problem there. That seems to be working fine. So I don't know if I've made a mistake in the way I'm using the keyboard here, or if it's just something to do with the emulator, but anyway, that's what we're doing. So we're going to be looking over the code that does this today, and it's all fairly straightforward. So the first thing we're going to be looking at is the print C command and the wait CH command, which are print character and wait character, of course. Now, print character is going to send a single character to the screen, or the terminal if you prefer. Now, the first thing we need to do is check that the screen is ready to receive some data. Now, what we do to do that is we test the port 177564, that's in octal, not decimal. So we're testing that port, and we're going to need to check the top bit. Now, if the top bit is 0, the port is busy, so we can't write our data. So we're going to do a branch if plus, and that will repeat back up to here until that top bit becomes -1. Then what we need to do is we need to send the data. Now, this example here is sending a byte from R0, move B for a byte there, and we're writing that to 177566, which is the data port matching the status port here. So we're sending the data, and that will print one character to the screen. Now, to wait for a character from the keyboard, we do basically the same thing. This time, to check if data is ready, we do 177560, and we're testing that with test B here to test a byte. And again, we're waiting to see if the top bit is 1. If it's 0, then we're going to branch back to here, and we're just going to wait until it's a 1, because 1 means in this case that there's some data for us to take. So when it is 1, we're then going to move a byte from 177562, which is effectively the key presses, and we're reading that into R0 here. So that's how we're reading a character here. And if you look just here, what we're doing is we're waiting for a character. We are then comparing it to character 27, which is 33 in octal, which is the escape key. And if we've not got the escape key, we're going to print the character we read in from the screen, and we're just going to repeat. So that's the test there of wait character for reading a character, and a simple test for printing a character to the screen. Now, of course, if we've got a print character routine, which of course we have now, we can then easily extend that into a print string routine. Now, in my tutorials, I know this is weird, but this is the way I've always done it. So in my tutorials, I use character 255 termination. And what we're doing here is we're repeatedly reading in bytes from R5 here, the register here, which is pointing to a string. You can see here we're pointing to my message here. You can see that here, and it's 255 terminated. So we're reading in a character, we're seeing if it's 255. If it is, then we're done, and if it's not, we're printing the character to the screen, and we're just repeating. So we've extended our print character into a print string there. Now we can also do some other things. We can also do a new line if we send a character 13, which is 15 in octal, and a character 10, which is 12 in octal. Now, a character 13 is a carriage return, and you need to think of a typewriter, the old mechanical typewriters, if you've ever seen one even. I don't know what the average age of my audience is. But if you think of the typewriter, you would move down a line, and then you would move the print header back to the start. Or if you think of a dot matrix printer as well, you've got the head and you've got the roller, so the page would move up and then the head would move across. And that's what we're doing here. Character 13 is carriage return, it moves us back to the start, and character 10 moves us down a line, and the two combined will start a new line on the screen, because of course we're not using a printer here. So that's how we do a new line. Now, I should point out, if you're feeling very adventurous here, there are a lot of other options that we can use. Basically, the PDP-11 will support a lot of ANSI terminal codes. If you go to my website, there's a link for them, and you will be able to see them. I'm not listing them all on my website because, to be honest, some of them don't work. Some of the more advanced ones don't work, but some of them definitely do. And this kind of thing is sort of related to that terminal emulation. So it's definitely something you want to look at if you're looking to do more advanced things. But for the UKNC, which has graphics screen memory, we're not going to be looking at that, because if we want to do more clever things, we're going to want to use the graphics modes to do them. So there we go. So that's how we can print characters and print strings. Now, the only other thing we're going to look at is how we actually show the registers to the screen. We can do that by calling this monitor function here, and that will just show all of the registers in one line. You saw that before. If we want to dump some memory to the screen, we use the memdump function here. We specify the label of the area we want to dump and the number of bytes here, and that will be shown to the screen. And to include that, we just include this file here. That's the monitor tools that you saw in the tutorials and you saw when I ran this earlier. We're not going to go into the details of how that works because it's pretty complicated, unfortunately. There's quite a lot of it. So it's way beyond what I'm looking at today. And this is just a simple example. Now, apart from that, you can see we've got the start here. We're starting at org-octal 1000 here. And that's really about all there is here. We've got some space for the stack at the end here. We seem to have to do that on this system. The stack seems to point to the end of the program when we run a new program. That's certainly new to me, but that's the way this system does it. And that's basically our entire code. I think we've pretty much covered it all here. So how do we actually compile it? Well, if you download my build script from my website, it's all pre-configured. You should just be able to hit F6 and you can have these options you can see here. That should just work fine for you. But if you want to do it yourself, you can do. Basically, what I'm using is this RT11 simulator or an emulator. I'm not quite sure how far this one goes. It might just be a simulator, but basically this is an R11 simulator which is emulating, I'm now flipping my words, the PDP-11 machine, and we're using the macro AES assembler on that emulation, and that's what we're doing. Now the first stage here is we are assembling it. This is running the emulator here, and we're running the command macro, and we're specifying the file to compile just here. This is build file. This is specified as part of my batch file, so that would be the file name if you were writing your own. That builds a file that we then need to link. So we then run this link command again through the RT11 emulator. This time we're specifying the name here. You'll notice we're stripping off the extension here because we need to do that, and we also need to make sure that the length of the file name is not too long because this system does have character length limits. And we're just creating an output map here. And then the final stage once we've done that is to run it. Now if we want to run on the RT11 itself, we run the name of the file we compiled .sav. That's an executable file on this system, so that can be run on this system, and that's being specified on the command line here. So that's starting the emulator, and it's running the file here that will have been built by this stage, assuming that stage worked okay. You can see I've got skips here to fail if anything went wrong. Now that's how we build for the R11. The UKNC is almost the same. The UKNC on that system, we're actually running a cartridge file for convenience. That's a very easy way of me working with all these systems, is if there's a cartridge available. And most of the stages are the same. We're compiling here, linking here. Then the only thing we're doing is we're using this special save to cart program, which is designed to convert a SAV file to a bin file for the UKNC emulator, and that's what we're doing here. And then we're running UKNC here, specifying to automatically run the menu option, and the emulator itself is specified to run the cartridge. If we just go here and cartridge, and then we specify our cartridge here, then you can see we get the output. But this is automatically saved, so once we run it once, we can then run it again. And you can see it just goes straight in there and gets the job done automatically for us. So there we go. So that's the PDP-11 and UKNC. We can go now get some basic text to the screen and read some keys from the screen, which is handy for showing the results of our programs, and also, of course, just pausing our program between stages. If we wait for a key, then we can basically just have a pause and then do some more work and show the results of a second stage. But of course, later on, we're going to be taking this further, and we're going to be doing some graphics and sprites and things on the UKNC. The PDP-11, of course, is a text-based system, but if you're into your PDP-11 programming, I think the UKNC is a fantastic system for you to look at, because it's far more like your sort of Spectrum or your Amstrad CPCs, those kind of systems that are a graphical system you can really have some fun with, whereas the PDP-11 server, it's certainly interesting, but it's not really there for the sort of gaming and for the visuals. So I think the UKNC is the preferable one, at least for me. Anyway, that's all we're going to be covering today. If you've liked what you've seen, please like and subscribe. If you like the videos, then YouTube recommends them to more people, so hopefully they'll like them as well. And if you subscribe, you'll see the later episodes, because I'm going to be doing some more on the PDP-11 and the UKNC. We're going to be doing some graphics on that UKNC, and we're going to be getting the Chibico mascot onto the UKNC. Anyway, I hope you've enjoyed this. Thanks for watching. If you've enjoyed this video today, please consider supporting my content. It takes 20 to 30 hours a week to keep making these videos. It's basically all I do when I'm not doing my day job, and it's only through the support of my patrons and the other sponsors that I'm able to continue justify doing it, essentially. You can back me on Patreon. I post a weekly update with the latest work on the current projects I'm doing. You can see one here, and also the newest videos. There's a large backlog of videos that are currently only available to the patrons, although they will all be available to everyone later on. And also it's the backers who I ask when it comes to making decisions on how to change the content in the future, what new content to create and things like that. You can see there was recently a survey of the backers, so I can plan next year's content. As well as Patreon, you can now become a member of my channel on YouTube. There's a join button you should see just below this video. You can use that. YouTube backers get the same content as Patreon. I just post it through the YouTube interface instead of the Patreon one. It's the same content every week. Also, if you prefer, you can go to my Teespring store and you can get some Chibi Akuma's merchandise or some Learn ASM merchandise if you prefer, if that's how you would like to back me. Links for all three are in the description of this video below. Anyway, whatever you decide to do, I hope you've really enjoyed this video. Thanks for watching today, and goodbye.